Hello friends, welcome to the channel. Today we will discuss about the Bayes theorem and its related topics. So agenda for the video is first we will discuss conditional probability, then we'll jump to the Bayes theorem, then partition theorem, and we will take very nice practical implementation where we will try to implement everything whatever we will learn on this video. So, what is conditional probability? It is a likelihood of an event transpiring due to its association with another scenario. So, let's take an example of snow and winter. So, probability of snowing today could be anything, right? It would be very less because snow normally happens in winter. But if you are given a condition that it's already winter today, winter in this season, so what is the probability now snowing? It will definitely increase, right? So providing extra condition for your probability and it's the whole framework and everything is called the conditional probability. Further, when we see the other examples, it will be clear more. Now, take an example of one scenario. You are going to meet a friend today, okay? And your parents are guessing, or what they would be guessing. Okay, it could be a girl, it could be a boy. So they don't have any other information. So if you see this Venn diagram, a 50% chance that it's a girl or 50% chance it's a boy. Okay. Now, if we give extra condition or extra information to your parents that the friend has long hair, so definitely it will improve the probability surety. For example, the condition is the friend has a long hair already. Now the probability of that being a girl would increase. Correct? 0.80%. Now, hope you're understanding this. Let's jump to the Bayes theorem, and everything you will see clearly when you implement this in the one of the example. So we will see that in a few minutes. So now, what is a Bayes theorem? It's just an extension of the multiplication law. If you see this multiplication law, the probability of event A given B, the event B has already happened. Now, what is the probability of A? That can be calculated through the intersection of A and B divided by the probability of B. Same thing, the second is also the same, but now it's reverse. The probability of A given A, probability of B given A. So now if we just deduce more on that, now we can equate both the things and we can find this. So probability of A given B is equal to probability of B given A into probability of A divided by probability of B. So this is our Bayes theorem, and we will understand it more when we see the real example. And to resolve the real example, we need one more theorem. This is partition theorem. Well, take an example of this girl and boy again, and we have a long hair subset inside. Okay, so now we want to calculate the probability of having a long hair. Okay, so this can be done. It's a simple Venn diagram equation. The probability of long hair intersection G plus probability of long hair intersection B. Correct? This is a first area. This is a second area. We can add both, right? And the total would be the probability of long hair. Correct? So now, after having this equation, now we can implement add the this multiplication law. So intersections can be decomposed into the probability of long hair given the girl into probability of girl, probability of long hair given B into probability of B, the boy. So this we will be using in the example, and these two things, Bayes theorem and the partition theorem, are very crucial to understand the business scenarios. Now, let's read this. Just pause the video for a few seconds and just read yourself what's happening in this problem. So, consider a test to detect a disease that 0.1% of the population have. The test is 99% effective in detecting an infected person. However, the test gives a false positive result in 0.5% of the cases. If a person test is positive for the disease, in the probability that you actually have. Okay, so now the whole scenario, just slowly we'll try to reach to the top level. First, what's happening? There are two events happening. One is a disease, second one is test. Okay, now the probability of having a disease in a population, the first statement is given that whole population, 0.1% of the people have that disease. So this is given, okay? And if you see in the Venn diagram, if you relate it with the Venn diagram, so the whole this universal Venn diagram, the d is equal to 1 means this portion people have disease, and this portion people don't have disease, okay? Now, as p d is equal to 1 is given, we can directly, by minus it with the 1, we can find the probability of not having the disease, okay? This is the 1. So these two things are already given in the question. Now, third thing, the probability of having a disease. So the precondition is the patient already infected. Now test is positive. This is also 99%. So if you see in the Venn diagram, in this area, we have put a condition that the patient who is coming for the test is already infected. So should just leave this area, because this area we don't need, because the condition is already given, d is equal to 1. Now, after d is equal to 1, what is the probability of t is equal to 1? Means the test is also positive. So this is 99%. So obviously truth as well. If someone has a fever and come to the doctor, they will obviously say that you have a fever, correct? So the probability would be high. So this is acceptable and given also. So now the fourth point is false positive. They have given us the false positive. So which is a type 1 error. If you see, in actual, person is not infected, but the test has shared the information that he is infected. So ultimately, the person is not infected, but the test is saying it's infected. So it's 0.5%. So 0.5 divided by 100 is this. So the all the given things are we have understood. Now, what is to calculate? Calculate is if a person tests positive for the disease, and what is the probability that they actually have it. So P is equal to D is equal to 1 and T is equal to 1. So test is positive. Okay, the test was positive. Now we need to find out whether this guy is already infected or not. So this is to calculate, and this can be done through Bayes theorem. So if D is equal to 1 and T is equal to 1, the test is already positive. What is the probability that he is infected? So to find it out, we can put a Bayes theorem. So just reverse it. The one is already infected and positive also. So the population, those who are infected, and what is the probability of the tests being positive? So if we have done 100 tests, what is the probability that those tests would be positive? So most of the things we know, this first term we know because this is given, this 0.99, and P is equal to D is equal to 1 is also given, which is 0.001. Okay, but this P is equal to T is equal to 1 is not given. The probability of having test positive. So what is the probability? We discussed as in the last slide that P is equal to T is equal to 1 is not available, which can be calculated through partition theorem, which we have seen. Okay, so P is equal to T is equal to 1 is the intersection of, if you see in the Venn diagram, intersection of this area and this area. If we plus both the things, then it will give us the probability of test being positive. Okay, so this area plus this area, and we will decompose it through multiplication law, simply applying the multiplication law. Now we have every details available now. Probability of T is equal to 1, D is equal to 1 is also available, P is equal to D is equal to 1 is also available, and P is equal to T is equal to 1 and D is equal to 0. So if you are not infected but still positive, this is also given. The probability of whole population not infected, this is also given, which is very high. So now we can find out, and we can find out probability of test being positive. So we have done the test. What is the probability that it would be positive? Which is this, which is very low and which is possible, right? we are going through the coronavirus, right? So we might be having a lot of tests, but positive would be very less, right? So which is, understandable. Now, after calculating this, we can just put the everything into this equation 1. Everything is already available. The last point which we just calculated through partition theorem. So after putting everything, we can calculate the D is equal to 1 given T is equal to 1. So test is also positive. What is the probability that the guy is infected? This is 16% chances. So this is a probability of having a disease when test is positive. It's 16%. Okay, hope you're understanding. This is very important. So test is already positive. What is the chance that he will have a disease? It's 16%. If you see in the reality, if you just come out of this base theorem concepts and just see in the reality, this is very low actually. So that means the test is not giving a clear picture. So normally when we have a positive test, immediately we just think that yeah, I have a disease, but 16% is pretty low. So correct. Now after we have understood everything, I will give you a challenge and just read it and try to resolve it. If you face any problem, just let's discuss in the comment section. I will help you out. In the end, let me ask you to get connected. On this channel, the target is not only the academics, but the picking the value addition and explain to the wider audience. So if you like these kind of content where the study is more business oriented, business focused, then please subscribe the channel and click on the bell icon so that whenever a new video comes, it is beneficial for you as well. Thank you. Thanks a lot.